Hi, my name is Phoebe Jones,
I'm Kat Rayburn.
and this is our final Ansys project. And this time we're simulating different objects in a wind tunnel.
Yep.
And so, as usual, you're gonna take Fluent, drag it in here. I'm gonna name this one the wind tunnel because it's gonna be the wind tunnel without anything in it. And then you're gonna right-click on geometry and do new design model or geometry.
3D is fine.
Okay, now that we are in the design modeler, you're going to go on the Z axis as usual, and you're going to click sketching. And now we're going to start by doing,
We're going to draw a lot of lines.
yeah, it's just going to be 3 horizontal lines because we're going to dimension them later. Now they're all, that's connected, yeah, that's connected. And we're going to keep them like that. And then we're going to dimension them horizontally. And then the length of the first one, we're going to do
1.1176.
And this is all going to be in meters. And then we're going to take our second line.
1.2192.
All right. And then we're going to dimension our third line.
We're going to make it 1.5748.
And these are going to be the 3 sections of our wind tunnel. And you're also going to draw a big horizontal line that spans across all 3 so that way you can constrain it. You're going to take that big line, you're going to constrain it to the origin. That way everything's in the middle, looking nice and happy. And now we're going to start with the vertical lines. So we're going to go back to draw, do lines, and you're just going to draw 4 random vertical lines. The length doesn't matter yet. And now that you have those, we're going to go back to constraints. You're going to hit midpoint and you're going to select them and constrain them to each point in the wind tunnel. And you put them right there, and then we're gonna dimension all of these lines.
Your vertical dimensions are 1.6256. And then we're going to do 0.6096. And that's for both of the small lines. 16.6. And your last one is going to be 0.889.
And then if you zoom in, that's kind of all the borders, not borders, but like sort of guiding lines to draw out the shape of the wind tunnel. And now you're just gonna play connect the dots, and you're gonna connect all of these points. Oh, oopsies. All right, and now that you have all of those connected, you're gonna hit the selector, and then we're just gonna kind of get rid of all of the lines in the middle. And then with that, you have your basic wind tunnel shape. And for now, before we start doing anything else, we're gonna duplicate this so that we have that geometry ready for the next 2, and we don't have to redo all of that. And so now we have all of those. I'm gonna go back into our sketching, and then as usual, concept, surfaces from sketches, and then you're gonna do the box select, and we're gonna select that as our surface, and then we're gonna generate. And that's going to be the surface for the first portion of the project. And then you're just going to save. And then, I have to try this part. We can exit out of the geometry. And now we can start with the mesh. All right, now that mesh has opened up, you're gonna go into the Z-axis again. You have your surface here, and the first thing we're gonna do is make all of our named selections. So you're gonna control click the top lines and the bottom lines, and then we're gonna name those the walls, and then you're gonna get your section on the left, that's the inlet, and then your section on the right is the outlet, just like all the other times, except now it's just a weird looking shape. And now that we have all of those, we're gonna go into mesh. First, we're gonna do a method, and we're gonna use the entire face, and we're gonna change the method to triangles, and then generate that. Now it's done.
It's got some triangles.
Has a lot of triangles.
Not enough.
And then to fix that, we're gonna do sizing this time. Oh, you're not big enough. Okay, there we go. You're gonna apply to the entire body again. And then for element size, I believe I did 0.01. And then you're not going to change any of these. And you're going to generate that.
It's going to take a moment. It's done.
I have a powerful computer.
Powerful computer.
And now you can see it's definitely a lot finer of a mesh. And this will be fine for this section, but there's going to be a bit of inflation for the other two parts. But for now, this is fine. And we're going to save that. We'll just save that into Ansys. And we can go ahead and close this out. All right, now that it's closed, we're going to go ahead and update that mesh. All right, we are back. The mesh is updated, and now we're going to go into setup. And it's going to open up this little launcher, and you're always going to do it in double precision. We'll start her up.
Takes but a moment.
Yes, it does. All right, setup has opened, and now we're going to go through everything that needs to be done in the setup. So first, you're going to go on your left to models. You're going to right click this viscous SST-K omega, and you're going to want to change your flow settings to K epsilon. And with that, you're going to want to turn on enhanced wall treatment and pressure gradient effects over on the left. Don't really need to touch anything else. You just hit OK. And then that should be everything under models. Next, you're going to go under materials and look at your air. For this, we're not really changing density or viscosity. For continuity's sake, we're just going to leave it the same. But then I believe, yeah, okay. And that's fine. And then you can close out materials. You can go to cell zone conditions just to make sure that it is air.
Sometimes it doesn't update.
Yeah, that looks like air to me. So we're going to apply that. And then we're going to go into our boundary conditions. And here is where we set the inlet velocity. So the velocity in the test section is supposed to be 15 meters per second. And after doing the math, the inlet velocity is going to be 5.625 meters per second. And then you can leave this turbulent stuff the same. Don't want to mess with it. Apply that and close that. And then you can check the outlet. Oh, that's fine. And then we can check the walls. And you just want to make sure that they're stationary with the no slip condition as always. All of that's fine and dandy. And then we can double check the methods. For this, you want to make sure the scheme is coupled and that pressure is second order and the momentum is second order of wind. And we have all of that. And then we're going to go into our reference values.
Compute from, so you don't have to update them.
Yep, it's always compute from inlet, and the reference zone is going to be the surface body. You can see it updated our velocity, and that looks good. And then we're going to go to initialization. I like to do 25 iterations instead of 10. And apply that, and then we can initialize it. And that is done.
Calculations, and you're going to do a small number of calculations.
I usually like to do like
Which is
750.
750.
It's a lot. And then we're gonna go ahead and calculate that, and we will be back when it's done, because it takes a minute. Okay, the calculations have calculated, and now we're gonna save this here, gonna X out. It takes but a moment.
A very long moment, but a moment at last. And now we're back.
That took less time than I thought. All right, and now we're gonna go into solution, which you're gonna see in another but a moment. It's really, really similar to the setup window. All right, now we're in our solutions page. First thing we're gonna find is the contours. So you're gonna go under results on the left, hit the plus under graphics, and you're gonna double click on contours. First up, I'm gonna do our velocity contour. And under here, you're gonna click velocity. You'll keep velocity magnitude, and we're gonna do all 4 surfaces. And we'll display that. And this is what our velocity contour looks like. You can see that it's 0 up on the walls, but then it gets higher in the test section, which is what you want. That's good. And so we have that. And then we're going to double click again. This one's going to be our pressure contour. It's just going to be static pressure. You're going to select all 4 surfaces again, save and display. And that's what it's looking like. It looks really cute. And again, it looks kind of similar to velocity, except it's backwards because it has the the difference in pressure is usually opposite of velocity. All right, now we have a pressure contour, and we're gonna do. Hello,
that was a noise.
We're gonna do. There we go. We're gonna do 2 more contours this time.
Total pressure.
Yeah, we're gonna do the total pressure contour, and then instead of static pressure, you're just gonna pick total pressure. Again, it's gonna be all 4 surfaces. You're gonna save and display that. And it's gonna look a little bit different, but she's looking good.
Scroll out and move to the side so that
I don't know how.
Okay, it's gonna, okay, yeah, there we go, huh. Yeah,
There we go.
it moves wherever your mouse is placed.
Okay.
And that is the total pressure.
Yep, that's our total pressure contour, and we have one more, and it's gonna be the dynamic pressure. And we're gonna go to this drop down, we're gonna pick dynamic pressure, select all of the surfaces and display. And that's gonna be our dynamic pressure contour. And now we're done with all of those.
Now we'll move on to the streamline patterns.
We're actually gonna do that last.
We're gonna do that last.
Now we're gonna go to the plots.
Oh, yeah.
And we're gonna pick XY plot. Do first. All right. So all the next 4 plots, they're all gonna be along the center line. So we don't have a center line able to pick for a surface. So you're gonna hit new surface, it's gonna be a line, and then you're gonna select the endpoints. What's the total length of this thing? And we're gonna add up the total length. And we're gonna divide it by 2. And so that's gonna be your endpoint points. So it's gonna be negative 1.9558 for your first one, and then 1.9558 for your next one. And then your Y values are just gonna stay on the axis, so you don't need to change those. And we're gonna name this line the center line. We're gonna create that. And then we can close that. And now we have the center line that we can use to graph all of these. So first we're gonna do the pressure plot. And we'll keep static pressure, and we're just gonna find it on the center line. We'll save and plot that. And it's gonna look a bit like laminar flow, if I'm being honest, but that's good. We have that. And now we're gonna do the velocity plot. You're gonna change your function to velocity, and you're gonna do it on the center line. We'll plot that. It's pretty much opposite to the pressure plot, which is what you want because they're inverses of each other. And next we're gonna do total pressure. Change that along the center line. Plot that. It looks really funny. And then last plot is gonna be the dynamic pressure. And change this one more time.
This one also looks a bit goofy.
Not as goofy.
Not as goofy.
I'd say total pressure is the goofiest. And we're gonna do 3 more plots,
Vertical distribution.
but except it's gonna be the vertical distribution. So you're gonna make another new line, except this time it's gonna be with the height of the test section. And so this time you're not really changing the x values, you're just gonna change the y values. So your first y value is gonna be negative 0.3048. And then your positive y value is gonna be just the positive value of that. So you're doing the vertical of the test section and it's centered on the origin. And then we're gonna rename this line. Call it the vertical line. And we're gonna create that. Now you can use that as a reference point. This is going to be the vertical pressure distribution. And since you're doing everything on the y-axis, or you're going to change the plot direction, you're just going to make it backwards. And then instead of position on the x-axis, it'll be position on the y-axis. And now it's just going to be, everything's basically upside down. But it's fine. Now the x-axis function is going to be pressure, static pressure. Oh, it's velocity.
Dynamic pressure and total pressure.
All right. Thank you. We're gonna change that. It's gonna be velocity. And just change her up, do it on the vertical line, and you're gonna plot that. It kind of looks like Finn from Adventure Time if he was put on his side.
Oh, I was gonna say a crescent moon.
Oh, that makes a lot more sense.
Is that also yours also makes sense? Word.
Now we're gonna do the vertical dynamic pressure. We're gonna again change up the plot direction.
Go.
Then position on the y-axis. Pick dynamic pressure on the vertical line. We'll plot that. Looks very similar.
Hmm.
And then we have one last plot.
Total pressure.
Will be the total pressure. And then same jam that we've been doing. I did a good joke, but I'm not gonna do that. And we're gonna pick total pressure along the vertical line and then plot that one last graph. You're just gonna look like this. They're all just kind of wonky variations of each other. And that's gonna be all of your graphs. There's a lot.
A lot of graphs.
That's okay. And we're gonna save this. We're gonna exit out of setup.
No.
I do the streamlines with it.
That's right. I forgot where streamlines are.
Yeah. And then we're just gonna close out of this.
I get confused between setup and solution.
Yeah. And now we're gonna go into results for the one last thing we have to do. All right, now we are in the solution page. You're gonna go on your z-axis. Now we're just adding streamlines. I can see the streamlines. Yeah, streamlines. And it's gonna be the velocity streamline starting from the inlet. Hello. There we go. And then I like to do 250 points instead of 25. And we're just gonna apply that. And you can see it looks pretty much just like the velocity contour, except when you zoom in, it's a bunch of lines.
One would even refer to them as streamlines.
Whoa, crazy.
Oh.
Yeah, it looks pretty much exactly like the contour, which makes sense, except it's separated into all of its streamlines. And that's going to be everything for part A. And now
we will meet you at part B.
Yes, we will. All right, now we're going to start part 2 with our copy of that first geometry. We're going to enter that design modeler. And now that it's open, we're gonna go into sketching and where'd it go?
I don't think you've.
But
We found it,
we
we're
were
zoomed
really
in.
zoomed in, but we have our copied geometry. Now all we have to do is add in the cylinder. I'm gonna start it at the origin. I'm just gonna draw a cylinder and then we can dimension it. Go here and then diameter.
Diameter is 1/10 of the height.
So that with that specification is going to be 0.06096. And it's going to be really small, but that's okay. That's what you want it to look like. And now we can do surfaces from sketches. Select that and then generate the surface. Now it's the same wind tunnel, but with a cylinder in the middle.
It looks a bit like when we did the wind around us.
Yeah, pretty much, except now it's in a wind tunnel.
Yep.
And now we're gonna save that, exit out. And then we're gonna open up our mesh. All right, we're in the mesh. It loaded up. You're gonna go on the Z-axis, and now we're gonna do the exact same thing as the first part, where we're gonna name all of our sections, except now we have one more. So we'll start with the walls. Do the inlet.
Got the outlet. In the circle.
I spelled that wrong. Outlet.
Outlet. There you go.
Then we're gonna zoom into the middle, and we're also gonna make the cylinder wall and edge.
Cylinder.
And we'll hit OK. Now you have all of your name selections for when you go into setup. Now we're gonna add that mesh. And then we're gonna do, once again, it's gonna be the method. You're gonna select the entire face as the body. And then for the method, you're gonna do triangles. We'll generate that. And then you got your triangles. Ooh, but now they're around the circle. And then we're gonna do the sizing. You're gonna apply it. First, it's gonna be a body sizing. For element size, we're gonna do 0.01 again. And then we're gonna generate that.
We do just fine. 0.01 doesn't break the computer.
Yeah.
Just enough.
It's not taking 18 years on the computer. And now we have a very fine mesh, but then we're gonna do one more, actually two more. Now we're gonna do edge sizing. So instead of based at the face, it's gonna be based around the cylinder. And then for element size, we can do it a bit smaller. And say 0. Let's do, we're gonna start with 0.2 and see how that looks. And then we can generate that. Right. Yeah, all right, we're gonna make it smaller. We're going to make it even smaller.
And then at this point, it'll take longer because it's a little bit smaller.
Yes.
And you get a little warning, but that's okay.
And now you can see that it's a bit more defined around the edge of the cylinder. That's good, that's what we're looking for. But then we're gonna do one more thing. We are going to insert, where's it? The inflation. So we're gonna apply it to the face. And then for the boundary, it's gonna be geometry selection. We're gonna select, again, the edge of the cylinder. And then for the inflation option, we're gonna do first layer thickness. I like to do like 0.15 is usually a pretty good one. We're gonna do, say, 40 layers with a growth rate of 1.1. And then we're gonna generate that. And this one takes a moment.
Yes. The mesh
All
finished.
right, the mesh finished. Now you can see a nice circle of squares around the cylinder wall, which is what we want so that it really encapsulates the airflow around that cylinder. Now the mesh is done. We're gonna control save that, and then we can exit out. And now we have to update our mesh.
A lot of this project is the same steps, but just modified slightly.
Yeah, a lot of it is really just modifying for the shape that's in the wind tunnel and then finding slightly different values.
You modify it just enough that you can't copy and paste things over. You have to go through all the other things to do with the slight change.
Setup. Time for setup.
Let's go to setup.
And again, it's going to be in double precision. And then we're going to wait for that to open. All right, now we are back in setup. And we're going to do pretty much the same steps as the first time. Change this to K epsilon. Going to turn on enhanced wall treatment and pressure gradient effects. Going to save that. And then we can close up models. We're going to go into our materials. And we're just checking out the air. And we're going to leave these constants. We're going to close that. And then we can go into cell zone conditions just to make sure that everything is fine and that we're still using air. And then we're going to go into our boundary conditions. Once again, change up the inlet velocity to 5.625.
A lot of the same things.
That's pretty much the exact same steps for this setup.
Your wall.
But now we're going to change both of these walls.
Yep. You just want them stationary.
With no slip conditions. It's pretty much the entirety of all of these projects.
We had one where they weren't.
Oh yeah, we did, didn't we? And then again to the reference values, compute from the inlet. The reference zone is our surface body. Then you have all of that information updated. And then we're gonna go check our methods just in case. Everything is looking good. And then we can run to the initialization. Change this again to 25. And then initialize.
Bam. And it'll take pretty quickly to initialize, but now we're going to run the calculation.
And we're going to run a lot.
A lot of calculations. 750.
And then we're going to calculate that, and we'll see you when that is calculated. All right, our calculations are done. And then we're going to save. Sorry, I just hit your hand. We're going to save that. We can exit out of setup. And then we're going to go right into solutions.
Yeah. Solutions is a lot like setup.
It's like the exact same.
It's the exact same. I get confused every It takes a minute.
Okay, my PC's working very hard. See, look how fast you worked. Now that we're in here, what are we getting? All right.
We're getting velocity and pressure contours.
All right, it's going to be the exact same thing as last time.
Velocity contour.
Oh my gosh.
Contour.
Contour. All right, and we're going to do contours of velocity. It's going to be all over. It's going to be every single surface. We're going to display that.
Zoom in on the circle.
And this is our velocity contours. You can see that with the cylinder, it looks very similar to when we did airflow around a cylinder with the velocity contours, which is good. That's what you want. And now that we have that looking nice and pretty, nice and beautiful, it's going to be the prettiest part of the party.
The pressure contour.
And it's going to be static pressures. We don't have to change that. It's going to be all over every surface. Then we're going to display that.
And it also looks a little bit like
that
cylinder, but we do have our additional ones where they're a little.
Yeah, because it's all over the wind tunnel.
Yes.
But that's good. And then next is the pressure coefficient plot. And so we're going to go into the XY plot. And it's going to be the pressure coefficient, and it's, I believe it was on the surface body, if I recall correctly. No, it wasn't.
Circle.
Oh, it was on the cylinder wall, wasn't it?
It's not on both of them.
Yeah, there we go. All right, it's on the cylinder wall. This looks a lot like the last project with the flow around a cylinder. it pretty much looks the exact same as the laminar flow pressure coefficient plot.
With some slight bumps and bruises.
Yeah, but otherwise it looks a lot the
Am I
same.
getting
Oh, there's no more plots. All right.
drag coefficient?
And then to find the drag coefficient, you're going to go out of the results tab and you're going to go to report definitions. And then we're going to do a new one. It's going to be force. It'll be along the cylinder wall. And can I rename you? Yes, I can. I'm going to do the drag coefficient. It's under the report output type. That looks right to me along the cylinder wall. And then we're going to compute and then hit OK. And then we can close that. And it's going to give you your drag coefficient at the bottom.
A little small.
It's a little small, but
A little small.
that's what it's supposed to look like. And that's going to be everything for part B. And we will see you for part C. All right, it's time for part C. We're going to open up geometry.
Design modeler.
Always a design modeler, never in the analysis thing.
Never
That thing
know.
is so goofy.
It's so scary.
Oh, wait, I'm on the right thing. There we go.
Yeah.
All right, we have our cute little shape. And then we're gonna draw a rectangle in here. I like to start it just anywhere. And then we can dimension it.
Are we going to midline it?
Mm-hmm.
After the dimensions, of course.
Mm-hmm. All right, for the horizontal dimensions, we were given a, correct me if I'm wrong, it was 5 meters? 0.5 meters.
0.5 meters.
That's why we check. I forgot. And then for the vertical length, we're just gonna make it really, really small. Like super tiny. 0.05. That's good. Yeah, it's good.
Mhm.
So small you can barely see it there at all, but we're gonna zoom in to show you that that's a flat plate and not a line. And then we're gonna constrain it. We're gonna midpoint constrain it to the origin. Okay. Where are you? Oh, that's why we're over restrained. Hold on, give me 1 second and I will fix that. All right, we're back and we're gonna try to constrain this one more time. Oh, and then we're gonna constrain.
I told you.
All right, so we just kind of moved where we started the rectangle and now the flat plate is nice and happy inside the test section. And so we're gonna do same old, surfaces from sketches, box select. We're gonna generate that surface back from button. And now we have our very, very skinny flat plate inside the wind tunnel. And we're gonna save that, close out of that. And then we're gonna open up our mesh. And now it's opening, it's almost there.
It's still waiting.
It's almost there.
She likes to wait long.
All right, we are here. And now we have our little flat plate in our wind tunnel. First thing, as always, we're gonna do is name all of our edges. And we're gonna,
As always.
hold on.
We have our walls as always.
Yep, we're naming all 6 of the walls.
Walls.
And then we're gonna do our inlet. Outlet. Gonna spell it ley lines. And then we're gonna zoom into our flat plate. Come on.
Zoom in. Grab that edge.
And then we're gonna do the top of the flat plate.
Up flat plate. Up.
And we're also gonna take it at the bottom. Bottom. And then that's gonna be all of your name selections. You got them all on the left. And now same old with the mesh. You're gonna pick method, select the face, and then do the triangles. We're going to generate that. Oh, you got triangles. And then we're going to insert a face meshing along the face. It's going to be not quadrilaterals. Yes, it's going to be that face. And then, no, that's wrong. That's not. I forgot the settings for a second. We're just gonna generate that face mesh. No, we're not.
No.
All right, I zoned out when we were doing that. It's actually supposed to be inserting sizing, and it's going to be face sizing. And then for usual, we're going to do 0.01 for element size, keep everything the same, and we're going to generate that.
And this should look relatively similar.
We're gonna, aha!
Aha!
There it is.
You lost it.
I lost the flat plate. Where'd it go?
Somewhere in there.
All right, now we're going to do a sizing again, but it's actually going to be edge sizing this time. And we're going to pick the boundaries of our little rectangle. We'll apply that. What is it? Oh, okay, that's fine. And then for element size, I'm going to do 0.0001. No, I'm not. I'm going to do 0.01. 0.001. Sorry, it's been a long day. And then keep everything else the same. And we're going to generate that.
It's going to take a moment to generate because
But-
it's such a small area. Scrolling.
And
There's your
now you can't really see it, but you can tell that the mesh is definitely more concentrated around that flat plate. You can see it when I pretty much press on it. And that is going to be the mesh for our flat plate. So we're going to go ahead and save and then exit out of here.
We made our plate a little flat.
It's a little flat.
It's flat.
How big is that mini?
Too good at making it flat. Update.
I wonder how many like inches that is.
Just hold one moment.
While we wait for our mesh to update.
Is it 3 zeros or?
Yes. All right, now our mesh has updated. Wow, that's tiny. It's 0.02 inches thick, so it's a very flat plate. But now that our mesh has updated, we're gonna go right into setup. And we're gonna do double precision as always, and then we're gonna start her up. All right, we are in the setup, and now we're gonna do same exact thing as we have the last two times.
Epsilon.
Enhanced wall treatment, pressure gradient effect. Where's that button? All right, okay.
I can move the thing back up.
All right, just gonna go back up here. And then we're gonna close that out. Double check that we are in fact using air. We're gonna close that. Additive materials, cells and definitions. We're definitely using air. And then we're gonna go to the boundary conditions, the inlet, and then our velocity is gonna be the exact same as the other two, 5.625 meters per second. I'll apply that. And then we're gonna look at our walls.
They're good.
They're good.
They're
great.
being walls. Outlet, inlet.
Okay. And then we can close all that up, check our reference values. And then compute from inlet as always, surface body as the reference zone. And then we can go down to initialization. We're going to do 25 iterations. And then initialize that. Now that that's done, we are going to run our calculations again with 750 iterations. All right, we are back. Those calculations are done, so we can save that, head out of setup, and then we're gonna go right into the solution as always. I almost clicked on the wrong one.
It's okay. Solutions takes a minute. Once again, same as setup.
Okay,
Getting velocity and pressure contours.
as always.
As always, we love our velocity and pressure contours.
Okay, we're gonna wait for this to open fully. And now we're in here. The flat plate is like
He's in there.
It's in there somewhere. It's just damn near invisible. But now we're gonna go down to our graphics. We're gonna do the velocity and pressure contours. First, we're gonna do pressure. And it's gonna be all over.
Mm-hmm.
We're gonna save and display.
Yeah.
Where did our wall go? It's practically invisible.
He's meshed, but not entirely.
All right.
Back after a while.
It's a bit of an issue. It turned out our flat plate was too skinny and it didn't show up in the mesh. But
No,
we
it's
fixed it.
here.
It's right here. And this is our brand new pressure there we go. Sorry, this is weird. This is our brand new pressure contour. It looks pretty similar to the first one.
So
but
now
then
you have
when
that lift spec.
when you zoom in, you can see that around the flat plate, it looks pretty similar to like it was around the cylinder, except obviously since this is really long, it's gonna look a bit different. But that's okay. And so now we're gonna
Do our
good morning.
Good
Now
night.
we're gonna go in with our velocity
contour.
Ooh, I can't spell.
You know, it's okay if you misspell.
I'm
Because you
not.
always go back.
I don't want
Let's
to
click
misspell.
everything.
All right, and it's gonna be around everything. We have a lot of named surfaces this time, but now we're gonna do the velocity contour, save and display that. And here she is.
See velocity a lot more.
It's all blue around our flat plate because of its no slip condition. And other than that, it looks pretty similar to the other ones. Hello, there we go. All right, and then what's next?
Plot the wall shear and skin friction coefficient.
Okay, so now we're gonna go into plots and XY plots. We're gonna do the wall shear first. And it's gonna be under wall fluxes. It's gonna be the wall shear stress. I wanna say it's on the either the bottom or we're gonna try the interior surface. No, it's not that. All right. It's not that either.
But it's wrong.
It's not that either. Okay, so you're gonna take it at the bottom of the flat plate, and when you close this out, it looks like that. It looks really funny, but it is supposed to look like that. And then we're gonna make one more plot. It's gonna be the skin friction coefficient.
Skin friction coefficient 5. Coefficient.
All right, and then you're gonna go back under wall fluxes, and instead of wall shear stress, you're gonna pick the skin friction coefficient, and then you're gonna take it again at the bottom of the flat plate. You're gonna plot that, and then it's gonna look really similar to your wall shear. There's only a couple differences. I know they look pretty much the same, but that is okay. And then lastly, but not least, we're gonna get the drag coefficient, and so it's gonna be the same as last time. You're gonna go under solution, report definitions. We're gonna hit a new force report for drag. We're gonna take it. Are you good?
Yeah, I'm fine.
We're gonna take it along the bottom of the flat plate again, and then we're gonna compute that, and we're gonna close it. And it's really small, it's 0.015. And that is gonna be everything for our final Ansys project.
Thank you for watching.
Thank you for watching.